go ahead and copy this warm-up at the top of your lesson describing qualitative graphs paper. What is the slope of the line that can be modeled by the equation 2x minus 1? Go ahead and copy that down and answer the question. Pause this video and resume it when you're ready. Okay, so if I remember correctly, that a line can be modeled by the equation y equals mx plus b. And so if that's the case, and I look at y equals 2x minus 1, then I can see that the m is the number that's being multiplied by x. And so in this case, the m would be 2, so the slope would be 2. The b is the y-intercept, and in this case, it's minus 1, so the y-intercept would be negative 1. So that's what we were doing with linear equations and graphs, and we're going to be looking at how qualitative graphs kind of have a connection to linear relationships, but are a little bit different. So what is a qualitative graph? Well, a qualitative graph represents a relationship between quantities visually without using numbers. So what you'll notice in quantitative graphs is that, qualitative graphs is that they have an x and y axis, but they don't have any numbers or scale. So like I drew here in the table, they might have like time on the x-axis and speed on the y-axis, but there's no numbers. And so the intervals, rather than being measured by a scale of time, it's just measured as the graph changes. So an interval is the period of time between 2 points of time or between 2 events. Intervals on a qualitative graph can be described in 3 ways. They can be increasing, decreasing, or constant. And they can be consistent, or they can be varied. So we're going to look at a simple example at the bottom here. And you may notice that on the x-axis is time, and on the y-axis is speed. And it looks like the speed starts off pretty high and then goes down at a constant rate, goes steadily down until it hits the x-axis. So what it's saying is that this is an example of something that starts off fast and then ends, and when it hits the x-axis, it means its speed is 0, it means it stopped. So this graph is meant to describe a train and one portion of a train's travel. So how would you describe what's happening? Well, as time increases, the speed of the train decreases. This is a linear function because it's a straight line. So what would this mean? Well, this is an example of where a train is coming to a stop. Well, it's just a train slowly stops. It just slowly stops over time. They can't stop immediately. They have to do like a slow stop. So what would happen if instead the train was increasing? If the speed of the train was increasing, then you would see the graph go up and not down. So in this next graph, the x-axis is time in hours and the y-axis is distance in miles. But this distance isn't like your typical kind of distance, like a total distance. This is the distance from someplace. So what you can see over time is, let's say you're leaving from home. So this might be like at 0, 0, you're at home. So at the beginning, you start at home. You're not away from your home. And then you start traveling and you're going away from your home, and the distance away from your house is increasing until at the end, interval 5, they are returning back home. So the distance is, they're getting closer and closer to home, so the distance is decreasing. So I'm going to label in my graph the parts that are increasing, the parts that are decreasing, the parts that are constant. So what you can see is that in intervals 1 and 3, the distance you are away from the place that you started is increasing. You're increasing your distance away from where you started because it's going up. So the distance away is going up. Then for 2 and 4, you're staying constant. It's pretty much a flat line. So you're probably staying at the same spot. Maybe you stopped. Maybe you're just slowly moving, but you're not really getting that much of a distance there. So 2 and 4 is where you're just staying constant because it's flat. And then finally, you are decreasing your distance away. Your distance away from your wherever you started from is decreasing until finally you hit the x-axis with, and that's where you started. So that means your distance away is now 0. So you don't have to go back to 0, 0 because time isn't 0 anymore, but your distance is 0. So that's why it hits the x-axis. And this could be a scenario of maybe you are going to the store and you're traveling and you maybe stop for gas and interval 2, and then you keep going to the store in interval 3, and then you're at the store for a little bit of time, pick something up quickly, maybe at the pharmacy, and then section 5, you head straight home. So that would be a scenario that would match this. Let's look at the gasoline. It's a good topic. And again, we're going to look to see which intervals of the function are increasing, decreasing, or constant, and then we're going to talk about a scenario that would make sense. So I'm going to go through and I'm going to highlight. And you can see as it starts out, the price of gasoline isn't 0, meaning it's not free, right? There's a price for gasoline, and we could this beginning point could be anything. Maybe it's like $4. And then it stays $4 for a certain amount of time, and then the price decreases. The price of the gasoline drops. Maybe now it's only $3.50. But then it stays the same for a little bit. I forgot to highlight that second one. It stays the same for a little bit. This would be interval number 3. So, and then in interval number 4, now the price of gas goes up, and now it's even higher than when it started. So maybe now it's like $4.10 or whatever that number would be, but it's a little bit higher than where we started. Then it stays there in interval 5, it stays at that price for a little bit. Then it drops slightly in interval 6, the price goes down a little bit and then stays back. It looks like it's actually back to what it was at the beginning for interval 1. So that describes the scenario of what we're looking at here. So if you go through and you number your intervals, the intervals is where the graph is doing something the same. Like the first interval, it's flat for a while, but then when it drops, that becomes the second interval. And then it's flat, that's the third interval. And then it goes up, that's the fourth one. And so you could also go through and label them and this identify which ones were constant, 1, 3, 5, and 7, which ones were increasing, number 4, and which ones were decreasing, numbers 3 and 6. So in summary, we learned about qualitative graphs. And qualitative graphs describe the relationship between two variables visually, meaning that there's the graph has lines or bumps or could even be curves in it to show what's happening. You can describe the graph by describing what's happening in each interval of the graph. And remember, the intervals are where things change, and then you can say that maybe during that interval it increases, decreases, or stays the same. Thanks for watching.